Hello everybody and welcome back to another day of Math 7. We've talked about in the past couple days theoretical and experimental probability. So theoretical being what we can expect to happen. The probability of getting a heads on a coin flip is 1/2. You would expect to happen 1 out of 2 times. And then there is experimental probability. So what happens when we actually do an experiment and record results. So we would expect to get a heads every 1 out of 2 times, but when we actually do it, we could end up getting 2 or 3 or even 4 heads in a row. So it's just probability. It's just recording the chance of things that can happen. And so that's the difference between theoretical and experimental. Theoretical is what we expect. Experimental is what actually happens. So today we're moving into probability and sample spaces. So what a sample space is the collection of all possible outcomes in an experiment. So what we're going to do is we're going to create a sample space of all the outcomes of rolling 2 dice and adding the numbers together. So up top here we've got our options, what we could get for the first roll, and on the side here we've got options that we could get for the second roll, and what we're going to do is add those together. So if we roll a 1 and a 1, well, when we add those together, of course, we're going to get 2. And if we roll a 1 on our first dice and a 2 on our second dice, then we're going to get 3. So we're just adding these together. We get 4 and 5 and 6 and 7. Now if I roll a 2 on the first dice and a 1 on the second dice, well, we're going to get 3. And then 2 and 2 is 4. 2 and 3 is 5, and 6 and 7 and 8. And then we can just kind of see what's happening here with our table. We see a little pattern start to emerge too. So 3 plus 1 is 4, 3 plus 2 is 5, 6, 7, 8, and 9. Then we've got 4 and 1 is 5, and pretty easy to keep going from there. 8, 9, and 10, and 5 and 1 is 6, and 7, and 8, and 9, and 10, and 11. And 6 and 1 is 7, and 8, and 9, and 10, and 11, and 12. All right, so these are all the possible outcomes that we can have. So how many possible outcomes? Well, if we count all these out, we notice that there are 36 possible outcomes that we could get. I know some of them are multiples, but we get them in different ways. So 2 different ways of getting a 3. Well, our first dice could be a 2 and our second dice is a 1, so that would be 3. But there's also our first dice being a 1 and our second dice being a 2 also gets 3. So even though we get the same number out of it, we got there in a different fashion, so it counts as a different part of our sample space. All right, so what is the probability of rolling at least 1 3? Well, we've got to count our 3 row here, so rolling at least one of our dice being a 3, so we've got 1, 2, 3, 4, 5, and 6 here. And then we've also got 1, 2, 3, 4, 5, and 6. So 6 and 6 is 12 out of 36, which is going to give us 1/3. So we have a 1/3 probability of rolling a 3 in our roll. So what we're doing now is just continuing on finding probabilities of these things. So what's this probability we roll a sum of 1? Well, what's the lowest number we can roll when we add these things together? We didn't really get a 1, did we? Because we're rolling... Oh, shucks. Can I undo that? 1 second here, sorry. There we go, my mistake. So we can't roll a 1 because the smallest number we see in our sample space is 2, because we're adding two ones together. So what's the probability of getting a sum of 1? Well, that's going to be 0 because we don't have any sides of the dice with 0. All right, so remember, our probabilities here is the total number of things that can happen in our denominator and the total number of things that we want to happen up top. So we can expect to have a denominator of 36 for all of these. So a sum of 3, well, if we count up here, we've got 1 and 2. There's only 2 ways we could make a 3. So that will be 1/16. Sum of 6, well, once again, there's only 36 possibilities. And we count 1, 2, 3, 4, 5 ways of rolling a 6. And that can't reduce, so we're just going to leave it. A sum of 7, well, we can get 1, 2, 3, 4, 5, and 6 ways we can roll a 7. So out of 36, there are 6 of those. Always reduce your fractions, and we get 1/6. Probability of rolling a 10, well, we've got 1, 2, 3 different ways we could roll a 10, which would be a 4 and a 6, a 5 and a 5, or a 6 and a 4. So remember that 4 and 6 and 6 and 4 are 2 different possibilities, but there are 3 of those. So always reduce, and we get 1/12. And the probability of rolling a 12, well, there's 36 possibilities, and only one way that we can roll a 12. We can roll a 6 and a 6, and that's the only way that we can get to a 12. All right, so is this going to be theoretical or experimental probability? Well, we haven't really done any experiment yet, have we? We haven't rolled any dice. All we've done is take a look at all the options we have when we do roll 2. So this is what we can expect to happen. So this is theoretical. All right, so now we're going to conduct an experiment. So what I want you guys to do, this will start on the next page, so be sure that you have that ready to go. This is just kind of explaining what's going on. So I know you guys at home don't have any partners or anything that you can do at this, but so our game board is on this next side here. So what I want you to do is you're going to go ahead and open up on your Chromebooks go ahead to Google, and you are going to Google search Dice Simulator. And it doesn't really matter which one you do as long as you can have 2 dice on there. I like this one at calculator.net because there's not so many ads as the other ones. I mean, I know we get a couple, but it's not that bad. And we can change the number of dice on it, but we're only doing 2. We only want to do 2. So let's head back to our assignment here. So what you guys are going to do is you're going to roll the dice and then find the sum of the dice. So you're going to add those 2 together. And what you're going to do is put an X in one of the boxes over the number on your game board. And what you're going to do is just repeat this process over and over until you get one of those numbers to the top. So you're not really playing to win here, but maybe you can take a guess at what number you think will get to the top first, and that can be the way that you win there on your own. So if you guess right, then you're good. If you guess wrong, then I guess you lose. So once you're finished, so I'll show you how this is going to go. We've got our game board here. So we're filling in the data we collect ourselves. So I'm just going to do a couple of examples here. So, I don't know. Let's say I think that 9 will get there first. That's just going to be my guess. All right, so what we're going to do is head back to our dice. You're going to roll it, and we get a sum of 9. Oh, look at me go. All right, so what I'm going to do, I'm going to go back and put an X in one of the 9 boxes. And then I will head back and do a re-roll. And I get a sum of 8. So I'm going to head back to my game board and put an X in the 8. And what you're going to do is repeat this until you get one of these columns all the way up to the top. And then after that, you will try to fill out this chart. So there's theoretical, so what we expect, and then there's experimental from your own experiment. So I can't give you any numbers to do for our experimental probability because this is going to be based on what you roll. So, go ahead, finish out this game with that dice simulator, and then go ahead and fill out this table. And that's going to basically be our notes section for the day. Not too much going on there, but just gives us an idea of how we create a sample space there like we did, and how many options we have within our sample space, and calculating probabilities based on that. All right, so after you finish up with this little activity here, there is an assignment in Canvas after this next page, so be sure you complete that and get that turned in to me. As always, there are as always, you can feel free to email me or send me a message on Canvas if you run into any issues, or you're having if you get stuck, having any difficulties, and I will try to reply to you as soon as I can. There is no IXL today, so once you finish up your assignment and get that turned in, you are done and good to go. But be sure you get this game done either. No need to turn this in. This is just kind of our notes activity, so kind of less notes and more activity, but you don't need to turn that in. This is kind of just to get us in the process of thinking how we think about these things. All right, so yep, if you have any questions, contact me and I will get back to you as soon as I can. All right, I will talk to you all tomorrow for our next lesson, and hope you have a great day.